Let's start this lesson off with a definition. It says that the definition of a function is a relation that takes one input value and assigns one and only one output value to it. So what does that mean? It means or your x can't repeat. Okay, when I was teaching this in high school, it really stuck with them. So I'm just going to share it if you want it. Or that your x can't cheat. So y can be crazy, it can do whatever it wants, but your x cannot repeat or it cannot cheat. Your domain is the set of all possible input values. Input values are another name for x values. And the range is the set of all possible output values or y values. Okay, so example 1, state the domain and range of the following relation. A relation is just basically ordered pairs. And then determine whether the relation represents a function. So our first one, we have 4 different ordered pairs. The domain are all of your x coordinates. So we are going to do squiggly bracket 0, 1, 2, 3. That are all of your x values. Ordered pairs are always in the form of x comma y. So we're talking about that first number in each ordered pair. So then your range goes with your y. Now we're talking about the second ordered pair. So squiggly fancy brackets. We have -2, 3. Here's another 3. Okay, so let's go ahead and write this. We got -2 and 3. 3 is already in this solution set. So I don't need to write another 3. So then the next one is 7. So it is okay that my domain has 4 values and my range only has 3 because one of these ranges repeated. Now, is that a problem when it comes to the function? No, y can do whatever it wants. It's just that your x can't repeat. So when you are looking at these x values, because they don't ever repeat, that makes this, yes, a function. So let's look at B. First, let's state the domain. So we have 2, -3, 4. I've already have 2 in here, so I'm not going to rewrite it. Now, if you notice on this first one, this always went from least to greatest because that's just the way that they were listed in this order pair. It doesn't matter when you have individual numbers. So if you want to switch that -3 and 2, go ahead, but it's not necessary if you don't want to. And then your range would be 7, 6, 9, and 10. So again, it's okay that the domain has 3 and the range has 4. They're not always going to be even. Can they be? Yes, absolutely, but they don't have to be. So is this a function? Well, when we check for function, we just care about x's. And because we have 2 2's in that x position, this is not a function. Now, when I have a set of ordered pairs, we just look at the x values. Does the x repeat? When I have a graph, we will use the vertical line test, which I will abbreviate as the VLT. And the VLT says a set of all points in the XY plane is a graph of a function if and only if every vertical line intersects the graph in at most 1 point. So example 2, determine whether or not the graph is that of a function by using the vertical line test. In either case, use the graph to find the domain and the range. So does this pass the vertical line test? Well, when I put a vertical line in here, nope, this intersects in 2 different spots. So this is not a function. Which really and truly, all it is checking is, do those x values repeat? That could be -1/2, comma 2, and -1/2, comma 2, -2, right? So that x value there is repeating, and so it is not a function. Now, In either case, state the domain and range. The domain and range from graphs can get a little tricky. This one's not too bad. When we find the domain and range, domain, we will always go from left to right. And that will always ensure that we go least to greatest because we're looking at that X value, which is essentially from last lesson, just a one-dimensional horizontal, vertical, or horizontal line. Going from left to right goes from negative infinity to positive infinity. Then your range, now we're going two-dimensional, goes from the bottom to the top, because that will again go from negative infinity to positive infinity. So your domain, and let's do this with a ruler. As you go from left to right, what is your leftmost X value? Well, it starts right here at -2. And that is included, so it will have a bracket. And then it's going to go all the way. What's my highest X value? Right here at 2. So I'm looking at where is this right side of my ruler crossing. And so at 2. Now I'm going to go from the bottom to the top. So I'm looking, where is this crossing? So as I go from the bottom to the top, here's where I first encounter my graph. And so that's at -2. And then it's going to keep going up to +2. So here the domain and range are the same. Now before, up here, I could list these values, right? Because I was given just these 4 ordered pairs. Here I cannot list, I have to use interval notation. So if we just take that domain, for example, if we go from -2 to 2, I can't just list -2, -1, 0, 1, 2. Those are only the whole numbers. We also have 1.5, 1.2, 0.5, 0.75, 0.8. We've got an infinite number in between. So I cannot list numbers. It has to go in interval notation. Now, this domain and range isn't too bad. It starts getting a little bit more confusing here. If you don't pick up the domain and range on part B very quickly, that's okay. In the last video of this lesson, we're going to go over, I think, 4 or 5 other examples of finding domain and range. So hopefully you are picking it up by the end of it. Now, if we use that vertical line test on this one, does it meet the criteria to be a function? Anywhere you put a vertical line, it only intersects in one place. So this one is a function. Okay, so now domain and range. When you look at this graph, which is a parabola, and we're going to graph this next module, what direction is this graph going? Okay, most of the time when I ask that question, the class will say it's going up. We can very clearly see that as these lines continue, they're going to keep going up. They're going to get higher very quickly. But if maybe show them with a different color. If I expand this out, it's not just going up. It's also, as it's going up, getting wider and wider, correct? So as this is going up forever, these numbers are going to keep getting wider and wider. So now I'm eventually at -1. I'm here at -2. I'm at -3, -4. Can I eventually get them over here to -10? Yeah, this chart's going to be way off the page, right? But yeah, I can eventually get to any number I want negatively. Same thing here positively. As this is going up, this is going further and further out. So we can see here at 4, at 5, at 6, at 7, I can go as high as I want as this graph is going up. So when you go from left to right, I use my ruler again, talking about this edge here. If the first thing I encounter is an arrow, that is negative infinity. And as I go to the left, looking at this edge here, the leftmost I touch is another arrow that's positive infinity. Now, using this edge here, as I go from the bottom to the top for my range, here is where I first encounter that graph. It does not matter where it's crossing this y-axis. That's not what I'm asking for. Here is where I first encounter my graph. What is this y value associated with this bottom portion of it? It's right here at 3. So this starts at -3, and then it's going to keep going up forever to infinity. Okay. Usually in class when I teach this, we're all good on this problem here because it just so happens that it's crossing right here at the start and the end of these. But that's not going to happen every time. In fact, it's rarely going to happen. And so we need to be able to find the domain and range of graphs more like this. Rewind this video if you need to see if watching it again will help you understand that domain and range portion. But if it doesn't, or if you don't want to rewind, that's okay. We're going to do 5 more examples of this. So hopefully by the end of those 5 examples, you're going to start picking up a little bit easier and able to find that domain and range on your own.